we're going to do one more video here, and we're going to talk about some really easy ways that kind of apply to a couple different things. Go ahead, Allie. Tell us some ways we can get kids moving in our classrooms, in our math classrooms.
A lot of us collect data in the beginning of the year for making graphs. We collect data for, trying to do a lot of statistical analysis. We want to know the average number of pets and, the mean, median, and mode and stuff like that. So we use, a lot of times it's even like walk into the class and give us the number of pets you have, the number of siblings you have. But a lot of data you can collect really quickly with kids moving and doing stuff. And then they're totally involved and they're keeping track of their data, but they're totally excited about it. So we do, like the wave is a big one. And the wave is where you just start with one table and say, how long would it take a wave to go like around the entire stadium? If we know there's, 400 seats in the front row, well, let's see how long it takes it to go around our room. Okay, if there's 5 people at that table, it seems like it takes, and we'll actually get the timer out, we time each group. It takes 5 people 4 seconds to do a wave. It takes 10 people as we add the next table, 8 seconds to do a wave. But it takes 15 people once I add the next, only 10 seconds to do a wave. And we'll go around the whole room a bunch until everybody's done it. Maybe we've even got up to 50 or 100 people. Let's go around twice, 3 times. The whole process might take 3 minutes. And we've got a ton of data that we can then find cue points. We can find mean, median, mode, average. You can do a bunch of standard deviation. So just in terms of collecting data, whether it's just like get up and do something, we do the wave. We've done a bucket brigade where you actually take a bucket of water, but I just use confetti or ripped up paper from the recycling bin, and I yell that I'm on fire, and they're trying to put me out, and we'll see how long does it take per person. So just how long do different things take? If you've ever heard the chicken fat video from when we were kids, I have a record player. Actually, it's online. You can just play it on your computer. But it's like a gym workout that we used to do when I was in gym when I was a kid. And
what's it called again?
It's called chicken fat. Go, you chicken fat, go away. It's hilarious. And we had to do it in gym like every day when I was a kid. Just find it and listen to it. Have kids take their pulse. Easy to find. Just do like the 6 seconds and add a 0 one because it can be really simple. And then keep track. It resting and my pulse is 60. We're gonna do chicken fat now for 45 seconds or for a minute. 1 minute in, check your pulse again. Let's stop. Write down your pulse. Oh, mine's up to 70. Do it for another minute, put it back on, and you gotta follow directions. There's like jumping jacks and marching, and after 2 minutes, what's your pulse? And it's just, there's really easy ways. You could just, you could come up with a million more, but just something that's moving and active. Another thing, like when we're doing proportions, I know we did the inverse one but if you're doing proportions and dimensional analysis, that dreaded word that so many kids freak out with, we'll actually run a race. I'll put 2 lines in the hallway, one at 0 meters and one at 20 meters. That's really short. It takes kids a couple of seconds to run 20 meters. But as soon as they write on their hand that they ran 20 meters in 5 seconds or 5.2 seconds, they can figure out how fast they're going in miles per hour. And you just get, it takes 5 minutes to time a class of 30 kids, 34 kids, 20 meters. And they've all got something writing it on each other's hand, they're passing the marker, and everybody's back in here trying to figure out, seeing it here, trying to figure out how fast they're going if they were in a car. Could a car keep up? So just little things like that.